Hello everyone, today we are going to discuss about the different number systems, which are the decimal, binary, octadecimal, and hexadecimal. The decimal has a base of 10, binary has a base of 2, the octadecimal has a base of 8, and the hexadecimal has a base of 16.
Hi, we're gonna talk about the brief history of number system. 100 or so years ago, the primary system that human used for calculation was a decimal number system, but computers and other technological advancement fueled the need for a more sophisticated and technologically number system. This is what prompted the birth of the binary number system, and so on the hexa and the octal number decimal.
Hi. The decimal number system is the one of the four main types of the numerical systems. The decimal number system consists of 10 digits from 0 to 9. These digits can be used to represent any numerical value. The base of decimal number system is 10. It is the most widely used number system. The value represented by individual digit depends on weight and position of the digit.
How we can convert decimal to binary. How? Since binary has a base of 2, its multiplier is 2. So 1, 2, 4, 8, 16, 32, 64, and 128. Since 128 times 2 is equals to 256. So that's over 156. So we are going to start with 128. So we're going to minus 156 and 128. So the equals will be 28. So that leaves us 1, 0, 0. So the 64 and the 32 will going to have a 0 binary number. Now since the left is 16, 16 minus 28 is equals to 12. That leaves us another 1. So 12 minus 8 is equals to 4, another 1. And 4 minus 4 is equals to 0. So that leaves the last two numbers, 2 and 1, will be 0. So the answer is 1001100 to the base of 2. That's the equivalent of 156 base to 10 to binary. 1001100 to the base of 2.
Now, let's proceed to the octal numbering system. The octal numbering system has a base of 8. Its binary number equivalent is divided into 3 bits, and it consists of 8 special characters such as 0, 1, 2, 3, 4, 5, 6, and 7. Now, without further ado, let's proceed. Let's take in the octal number 153 and separate the numbers 1, 5, and 3 in order to work cleanly. Since one octal digit is equivalent to 3 binary digits, we are going to group each digit by 3 and convert it by using the concept of 4, 2, and 1, then place them under each digit. The 4, 2, and 1 will serve as number markers. Next, we are going to find and add the number markers needed in each octal digit in order to give the equivalent of each. For this, we need to place a binary 1 to correspond the given octal number. For the first octal digit, which is 1, its number marker equivalent is 1. For 5, its number marker equivalent is 4 and 1, since when added, it will be equivalent to 5. And for the digit 3, we need to place binary 1 under the number markers 2 and 1, since 2 plus 1 is equal to 3. Next, we are going to put the binary 0 to all the number markers unneeded for each digit. For digit 1, we have the number markers 4 and 2. For digit 5, we have 2. And for the digit 3, we have the number marker 4 that is unneeded. Now disregard the first two zeros on the result since binary numbers have to start with 1. Then lastly, add the base of 2. And so the binary number equivalent of the octal number 153 is 110111.
Hello everyone, I'm gonna discuss to you the hexadecimal, one of the 4 number system. Hexadecimal, also known as hex, is a positional number system with the base of 16. It uses 16 distinct symbols. Most often uses is 0 to 9, which represents itself, and A to F, that represents the number 10 to 15. Now I'm gonna show you how to convert hexadecimal into binary. First, you need to divide each hex number and place 4 bits under it. Next, put 1 under each bit number that when you add, the sum will be the value of the hex number above. And put zeros under the rest of the bit numbers that doesn't need it.
So a binary number is expressed in binary numeral system in which it has two symbols, 1 and 0. Each digit is represented by a bit. So for today, I'm going to teach you how to convert binary into decimal, octal, and hexadecimal.
So first, I'm going to teach you how to convert binary into decimal. Here's 11000100. You need to count all the numbers starting from the right by using the power of 2. Once you're done, count the value of the 1 and ignore the value of the zeros. We get 1, 28, 64, and 4. Next is to add them, and that is the decimal value of this binary. It's 196. To convert binary into octal, you have to group the numbers into sets of 3 starting from the right, and then count the values of the 1 by using the power of 2, same as what we did when we're converting the decimal. And that will be our octal. So, our first set of 3, we get 4. The second is 0. And the last is 3. So, our octal will be 304. Next is, we're going to convert binary into hexadecimal. First, we need to group them into 4 and count using the power of 2 starting from the right. And then we will count the value of 1. The first set is 4 and the second is 12. We will not put 1, 2, 4 because the hexadecimal numbers from 10 to 15 is equivalent into letters. 10 is A, 11 is B, 12 is C, and so forth. So instead of putting 12, we will put C. So our hexadecimal is C4.